I'm recording now. So conservation law of energy is applicable on every aspect of our physical life. What the conservation law of energy states is that in an isolated system, the energy is not created, not destroyed by, but it is transformed from one form to the other. So in an isolated system, the energy is conserved pretty much. The question that we may have here, the question that we may have here is, whoa, just wait, what is the isolated system? The isolated system, the definition of the isolated system is that the mass of the object is not changing and there is no other forces beside the forces that we have taken into the consideration. What does that mean? So if we are saying that the system is a frictionless, the contact between the object and the surface is frictionless surface, then suddenly there is a friction there that is not an isolated system because we haven't taken that force into the consideration. If we are saying that we are dropping an object from a certain height and we are assuming that there is no friction as a result of the air resistance, but in actually there is, then we are not taking that force into the consideration. That doesn't make it an isolated system. If you are taking all the forces that the object is experiencing into the consideration, then you may say that this is an isolated system. But the thing is that the isolated system is a system that it is the energy is conserved. So you can go even on the other direction. If the energy is concerned, then if the energy is conserved, then the system is isolated. Okay? Now, let's see this example here. 25.0 kilogram object falls 240.5 meters. What is the speed of the object just before impact the ground? Do you remember those kind of questions that we were doing on kinematics? I hope so. Yes. Okay. So now we will solve it in two ways. You will solve it using kinematics and I will solve it using energy. Go ahead and solve using kinematics equation. Being at the top of the cliff, this object, what is the energy that this object possesses in terms of mechanical energy? Gravitational potential energy. Good. So the conservation law of energy in an isolated system, and we are assuming here that we are dealing with an isolated system. Why? Because we are not mentioning anything about the force of friction. Is this in reality an isolated system? No, because as the object is dropping from this height, the object is experiencing the force of the resistance of the air. So anyway, the conservation law of energy in an isolated system is saying that mechanical energy at the initial position is equal to the mechanical energy at the final position, and at any point in between. But we are interested here only for initial and final. So mechanical energy, we said yesterday, it is the sum of kinetic and potential. And it doesn't matter in which position you are at. one not. It doesn't matter at what position you are at the initial or at the final, always the kinetic mechanical energy is equal to the kinetic plus potential energy. And this potential energy, as we said yesterday, can be gravitational or spring. Doesn't really matter. So now, at the initial position, what do we have? Since the object is at a certain height, we have only gravitational potential energy. Kinetic energy in this case is equal to 0. How do we know that is equal to 0? The object is dropped. Okay, that means that the velocity is equal to 0. So 1 over 2 mv squared initial is equal to 0. And then at the end, as it is reaching the ground, right before it reached the ground, what do we have on the final mechanical energy? Kinetic or potential, or both? Okay, kinetic only, because potential is equal to 0, since the height of the object in comparison to the ground is 0, so then we have only kinetic. So now the conservation law of energy will be expanded as this. The gravitational potential energy at the initial is equal to the kinetic energy at final. Okay, gravitational potential energy formula is mg height initial, and this will be kinetic energy formula is a 1 over 2 mv squared final. Now, as you see here from this relationship, we can just simplify masses. Mass will be irrelevant on this case, okay? And this now turns to be a kinematics equation. So V final will be the square root of 2 times G times height initial. And now we know what G is, 9.81, and the height is given as 240.5. I don't know why I picked that number, but. And then I have an answer here saying that is 68.7 meters per second. And I bet you, Nicole, what is your answer for when you use kinematics equation? It should be the same. Yes. So again, this is an example of proving that anything in physics that you have seen up to now can be solved using energy. Okay. So now we have a snowmobile driver with a mass of 120 kilograms traveling at 35 meters per second slumps into a snowdrift. If the driver sinks 0.60 meters into the snow drift before stopping, what is the force applied by the snow drift? Okay, so see what do we have here? We have as the initial, so the conservation law of energy is mechanical energy initial is equal to mechanical energy final. Okay? Agree? Yes, good. What is the situation at the initial? What do you have? You have an object with mass given and a velocity of 35 meters per second. What type of energy you are dealing with here? Great. What is it? Yes. So we have kinetic energy initial. And now, Here we see that the driver is sinking into the snowdrift, and it is sinking for 0.60 meters. So it is as it is thrown into the snowdrift, it is going inside for 0.60 meters. And then we are asking here, what is the force that the snow is applying to the object? This tells us that whatever is the energy that we have initially is converted into work. Okay, based on the work energy principle, we can say that this is the same as the work done by the snowdrift, the force, the retarding force of the snowdrift to the person. Okay, so based on what we said before, this will be equals to the force applied on by the snowdrift times the distance that the object is moving. Does it make sense? So now what we have is 1/2 mv squared initial is equal to F times d, or 1/2 times 120 times 35 squared is equal to force that is applied by the snowdrift times 0.60 meters. From here, we can find that force is 0.5 times 120 times 35.0 squared, the whole thing divided by 0.60. What is this force? Because it is push. Well, yeah, but we are asking for the magnitude here. Yes, it will be negative because you are losing energy. Okay, will be negative. It's the same as the force of friction. The force that the snowdrift is applying to the person is the opposite of the motion. Okay, the force itself will be negative, but we are looking for magnitude. Okay. Yeah. So let's move to the other example. A 15.0 kilogram object is thrown vertically down from the top of a 150 meters tower with a speed of 15 meters per second. What is the speed of the object at the bottom of the tower just before it hits the ground? Very similar to what we did as the first example. You can do this again with kinematics and with work and energy. So now you know if you have a question that is a kinematic question, you can see if you can solve it using energy, and then you can do the work with one way and then check your answer with the other way. What do we have in this situation is you have a cliff, a height that is 150 meters tall or high, and then you have an object with mass 15 kilogram. This is the situational diagram, and at the initial velocity is 15 meters per second. The simplicity of the work and energy principle and work itself is because you don't need to even consider direction. Okay, so this is the simplicity. And they are looking for the velocity here at the final. So what is here? This is the ground. Okay, so you always will start mechanical energy at the initial is equal to mechanical energy at final. What type of energy do I have here? Kinetic and potential. I have both. Why do I have both? I have both because the object is at a certain height and it has a certain velocity. And then here at the ground, I have only kinetic. So the formula will be 1/2 mv initial squared plus mg height initial is equal to 1/2 mv final squared. We know everything but v final, but guess what we have here? Mass even can cancel out. You can see it is the same, is scalar, is not zero. Well, then you can cancel it out. It's the same on every term. So you can go, but if you don't see it, it's fine. Still, you will have the same result. I remember in one of the questions, someone was asking me, what is the mass? And I said, well, you don't need the mass because will be simplified. And then I don't remember was it she or he. And then it says that, well, how can I calculate it without mass? And I said, if that bothers you, put a number, any number on it will do the work. Put a number, say that mass is 10. And keep this as a strategy, even in a higher level. If you see that you because sometimes brain works, I don't know. And then if you need a number for a mass and mass is not given or a quantity is not given, that means that it's not irrelevant. But if it is, and you want to see a mass, put a number there. Put 10, put 1. And then you will have the same result. So even if you don't see this, and I will do the example as you don't see it, times 15 times 15 squared plus 15 times 9.81 times 150 equals to 1/2 times 15 times v final squared. Do the calculation tell me what is v? So an answer here is 28.14 meters per second. I'm considering that this is right. Let's move now to the next one. 120 kilogram object is raised 12 meters and then released. What is the speed of the object? 2 meters above the ground. Okay, so 2 meters above the ground. If you have an object that is raised 12 meters, so this is 12 meters, the total here is 12 meters. Here, this being initial. We are looking now for a situation as the final here, that is 2 meters above the ground. Okay, so we'll start. Mechanical energy initial is equal to mechanical energy final. What type of energies do we have at the initial position? Kinetic, potential, or both? Answers on the chat, please. It is only potential, so potential energy at the initial. And then here at this point here, what do we have? Kinetic, potential, or both? Answers on the chat? Both. So we have kinetic and potential. And now we write the formulas. So mgh initial is equal to 1/2 mv final squared plus mgh final. So mgh initial is 12, h is 12. And again, mass here can be canceled out because it is the same on all the terms. We are talking about the same object. So 9.81 times 12 is equal to 1/2 times, we don't know, this is what we are looking, speed, v final squared, plus 9.81 times 2 meters, because this is what it is at the final. In your calculator, the speed will be, so it is 6.0 meters per second. Okay, just so that you'll keep it into your record, probably the answer, check the answer for this because I'm getting a different number, 56.28 meters per second. check your calculations. Probably there is a mistake or a typo. Now we are talking about a non-isolated system. A non-isolated system, as I said, is a system where not some energy is lost. It's not that it is the conservation law of energy is not true, but some energy is converted into either heat or light in majority of the cases. But what we will see here most likely is the heat. So when we have a 5.0 kilogram bullet enters a block at a speed of 250 meters per second and exits the 25 centimeters wide block at 120 meters per second, what is the force applied on the bullet by the block? So I will draw the situational diagram here. So you have a block which we are assuming that is stationary. So it stays there forever, for the situation that we have at. And we have a bullet here that is entering with a velocity of 250 meters per second. And it is leaving the block that is 25 centimeters wide with a velocity of 100 velocity leaving the block. So let's say it final, so 120 meters per second. So while the object is traveling into the block that is 25 centimeters or 0.25 meters, the object is losing some energy. And how is it losing it? It is losing it because it is friction between the bullet and the block, okay? So as the initial position, what do we have? So as the conservation law of energy is always the same. Mechanical energy initial is equal to mechanical energy final. It doesn't change. You can have loss of energy here and there, but it doesn't change. It doesn't change. So initially we have kinetic energy. So kinetic energy initial, and then we have some work that is done by the block on the bullet, work done by the block on the bullet, that is force applied on the block from the block to the bullet, plus kinetic energy. Okay, does this make sense? So 1/2 mass of the bullet times velocity, I will say they are both BB bullet, and initial velocity squared is equal to work that is, we said, is force times displacement. So will be a force that the block is exerting into the bullet. We can say, for simplicity, force of friction between the block and the bullet, or we can say BB, block onto the bullet, times displacement. This is what we know from work, plus 1/2 mass of the bullet times final velocity squared. On this relationship, we know everything but the force. So we know mass of the bullet is 5 grams. So mass of the bullet is 5 grams, which means 5.0 times 10 to the power of -3 kilograms. Initial velocity is 250. So the relationship will be 1 over 2 times 5.0 times 10 to the power of negative 3 times 250 squared is equal to force that we are looking for times 0.25 plus 1 over 2, 5.0 times 10 to the negative 3 times 120 squared. So use the calculator, find the force, and tell me what is it. So now let's see another example. We are considering an inclined plan that a mass of 25 kilograms is at a rest at the top of 15 meters height inclined plan sliding down. At the bottom of the plane, the object has a speed of 14 meters per second. What is the heat that was produced? And force here is 4.31 newtons. Okay. Okay. So try drawing the situational diagram here, and then try solving it without me doing anything much time. So now we have this as a situational diagram. You are at the incline, and then you have an object that starts initially at the rest. And then you have that is 15 meters height. So this one here is 15 meters height. And then as it is sliding down at the bottom here, final, is reaching a velocity of 14 meters per second. Okay, so now mechanical energy initial is equal to mechanical energy final. At the initial position, what we have is only potential energy, which if we are doing is equal to kinetic energy, then we will have a higher velocity. But since the velocity at the bottom is given, that means that some of the potential energy as the object is moving down the incline is transformed into heat. How will you know it? It's saying here how much heat was produced. That means that this is not an isolated system. Okay, there are some forces here that we are not taking into the consideration. So this means that this potential energy is going to kinetic at the bottom of the incline, and some heat that is produced. So now potential energy at the top will be mg height initial equals to 1 over 2 mv final square plus heat. So heat energy will be, what is mass? 25 times 9.81 times 15 minus 0.5 times 25 times 14 squared. So from here we find that heat is whatever it is that the calculator is giving us. So the heat is 1,228.75 joules, so that is lost as a result of the friction that exists between the object and the incline. And now, based on the work energy principle, we can say that work done is equal to the energy that in this case is in the form of heat. Work is force, and the force that we are dealing with here is force of friction times D is equal to 1228.75. Since the incline is 35 meters long, then we can say that force of friction is 1228.75 over 35 meters, and then you will have divided by 35 equals to 35.1 newtons, not meters, newtons. And this will be the force of friction. Now, I will post the practice questions and then we are done for today. So those are the practice questions that you can practice on. And as always, the answers are on the brackets. If you work on them and you cannot find the answer or the correct answer, please show up on tutorial and we will deal with the questions. This resumes the lesson for today.